All right, section 4.4 and 4.5 I'm going to put together. I'm going to try and keep this short because I know some of the problem solving video lessons have been quite long. It just takes time to solve those problems. But this section is actually one of the more interesting just from a knowledge standpoint. So if you look at the screen in front of you, we're looking at car tires. And if we talk about race cars, and in particular F1 cars, Formula One, that's the little ones that look like flying planes. When you look at their tires, there's something really unique about them. They have no treads on their tires. So the magnitude of the friction acting of the rubber tire on the road is really dependent on how much surface area comes in contact with the road. So these race cars don't have treads, so they can maximize the amount of rubber that touches the asphalt. The one problem though is because they don't have any treads, if there's any moisture on the track, whether rain or fog or something, then they actually become less, they have less friction and they become less stable for staying on the racetrack at those high velocities. So they don't race. So this is just an interesting picture. You'll see there's no treads on these tires. Whereas a regular car that you drive, or will be driving since you're at that age to start learning how to drive, has grooves in it. And the grooves aren't there to grab the asphalt. That's sort of a misconception. The grooves are there to actually force liquids, be it rain, snow, ice, whatever's on the road, out of the way. Okay, so liquids are very difficult to compress. It's one of the principles behind hydraulics. You can't squash water very well. It's very difficult. So when water gets on the road, you can see down here, when water gets on the road, it gets underneath your tires. And if you cannot clear the water out from underneath your tire, what can actually happen is it can build up underneath and create this situation, which we call a hydroplane. So if your treads are too worn down, too not correct for the type of driving you're doing, you can have a buildup of water underneath your tire that's almost incompressible, and this little space right here is what causes all the problems, because now the rubber of your tire is not touching the asphalt, which means you're in a frictionless state, which means you're hydroplaning, which means your car is now out of control. So when you're driving along the highway in particular, if you see water on the road, it's really important to slow down. Okay, because if you hit that water at a really high speed, you're going to come into it and your tires aren't going to be able to evacuate that water quick enough. You're suddenly going to be floating on this thin layer of water at a very high velocity. You've just got the makings of a really nasty accident about to happen. So you really have to understand that the idea of hydroplaning and trying to drive on a frictionless state is super dangerous, especially at this early point in your driving career. So when you see water on the road, slow down, be smart about it. It's really, really important. Secondly, and I'm not going to read this whole thing, you can pause it and take a look at it. You need to know whether your car has ABS, which is an anti-lock braking system, or is just a traditional mechanical brake. If you have ABS and you put your foot down really quickly, you'll feel it pulsing back at you. Okay, and it's really important to know that, because if you learn to drive on a non-ABS vehicle, they'll teach you to pump the brakes when you have trouble. So you can pump the brakes to slowly bring the car to a slower speed. Okay, but if you have ABS, you do not want to pump the brakes because it confuses the ABS and then it doesn't work well. Okay, so right in here, you need to know the vehicle you drive. Do you have ABS or not? Because it really dictates how you respond in an emergency with your braking procedures. Okay, crumple zones, these are really important. We'll talk more about these when we get to energy and those types of things, but these are links. If you go to the PDF, they're worth watching. They're a bit of an eye-opener on how your car behaves when it's rear-ended, when it's hit from the side, those types of things. And that's a really good piece of information to have when you're driving in the back of your mind, because you have a greater appreciation for how your vehicle works. It's designed to crumple, it's designed to brake, it's designed to transfer when we get to the energy unit. It's designed to transfer that energy around the occupants so that you don't get damaged, but your car does. So worth watching those. Take a look. A couple of questions here from 4.4 just to get your brain thinking a little bit. Okay, this one's really good when you talk about tire pressure. It's very important. Okay, and for the athletes in the crowd, again, I'm not going to read this whole thing, but I know there are some skaters out there that'll be interested in how ice skates behave on ice and in terms of the coefficient of friction. And in particular, there's some interesting stuff here about the temperature of the ice surface. For the mechanical inclined folks, you have bearing design. So you have a packed bearing down here. This is a typical rolling element bearing. Okay, so you have little tiny points of contact. That's how this works. It's decreased the surface area greatly, so it's just sort of rolling on those tiny little edges of all those ball bearings. Okay, to have something like this, which builds on that hydroplaning model we just talked about for cars, where that fluid down here, it's almost impossible to compress it. So this central axle floats inside that yellow liquid and never touches the edges. So you're trying to decrease the amount of friction. And again, it will roll really nicely. Again, a nice little read there. So have a look. Something called near frictionless carbon. Just this number right here is really fascinating, 0.001. If you have any pots and pans at home that are Teflon, that's a non-stick surface that was used to be put in a lot of cookware. It's sort of phased out quite a bit because it had some carcinogen connections, so people use it less. If you do have pans that have Teflon in them, do not use metal flippers or scrapers or anything, because you do not want to scrape the Teflon off the pan. That's really important. Again, another nice little read. And then this is some good stuff on car safety and general information. If you're learning to drive, this is valuable information. I'm not going to read it to you, but I'm going to strongly recommend you think about it. And then I'll just leave you with this idea. The ancient Egyptians used rolling logs to move large blocks of stone when building the pyramids. How is the physics of a rolling element bearing similar to this ancient method of reducing friction? Okay, now I'm not going to go through that. You can think a little bit about that and go, that's really fascinating. So I'm going to keep this short because the other ones are long. Thanks for tuning in, and that's it for Chapter 4.